All right, here is the Module 2 quiz review. So here is a absolute value inequality, which actually we just saw, right? Write your answer as an inequality. So we won't even need the graph or the interval on this one. Now we need to isolate that absolute value, so divide both sides. I'm going to divide both sides by 4, right? Now that becomes a phantom 1. And so what do I got? I got the absolute value of x plus 3. And what 24 divided by 4 is 6. Now, that, of course, is not going to change the inequality, although if that was a negative 4, it would. And now I'm ready to break this up. Now, this is the first time that we've seen an absolute value on the right side. It doesn't matter which side it's on, by the way. You can still split it up, which I'm going to do. So I'll say 6 is greater than x plus 3. That would be a true statement. But also over here, I can compare negative 6 with x plus 3. I just have to flip that inequality, okay? So now it's negative 6 is less than x plus 3. Now, for those of you that see right here that it's not eating the absolute value, you could say this is a compound inequality, okay? And that's important to know. And so, like I did before, even right now, if I were doing this on my own, I'd say compare this with negative 6 like this, okay? Just put it on the other side of the absolute value. That, however, seems to confuse students, so I'm not going to do that. Although you could, okay? So this is an and statement because it is not eating the absolute value. And so I can go to this, well, both of them, both these inequalities, just subtract 3 from both sides, right? Oh, that's going to clear that out. So I'm left with x and 3, so that's 3 is greater than x. And again, you can just put an and statement right here, but subtract 3 from both sides on this side. X is, well, I guess compared to negative 9 is less than x. There we go. Okay. If you want to write this as a compound inequality, because they do look cool, you can compare this with low number first and then the higher number second. It's eating the x, and then it's eating the 3. Boom. Yeah, so I understand some of you don't like the x's or the absolute value on the right side. You could flip it if you would like. You'd make it 4 absolute value of x plus 3. And you're still comparing it with the same value of 24. But notice that this original inequality was eating the 24, so it needs to continue eating the 24. If you do this, this one does want interval notation. So here we go. We will show the graph and, well, the interval. But let's go ahead and break this up. So here we go. 7x plus 9. If it were greater than 32, that would give us a true statement. But also 7x plus 9, we'll compare this with negative 32. But flip the inequality there. Now this one is eating the absolute value, so this is an or statement right here. And again, when we get to the graph portion of this, we should know that it's an or statement because the two lines should go outwards like this, okay? So, well, let's use some principles of equality here. So add 9 to both sides, sorry, subtract 9 to both sides of both inequalities. All right, so that zeroes that out, so I'll drop my 7x is greater than 23, it looks like. That zeroes out there, drop my 7x is less than negative 41. None of these are very convenient values, but divide both sides by 7 is a positive coefficient, so it's going to keep the inequality the same. So it looks like I get x is greater than 23/7. Or, I'll put the or statement in here in a second, x is less than negative 41/7. There we go. Negative 7. There we go. All right, and again, this is a or statement. There it is. Okay, so there's our inequalities. Now, of course, it didn't ask for the inequalities, right? Just wanted interval notation. So while I am going to do the graph, of course, for you, that would not be a requirement, but I like it. So here's my line right here. I'll put 0 in the middle. I'm comparing positives and negatives, so there's 23/7 on the right and negative 41/7 on the left. So the first one, 23/7, that's an open circle because it does not equal 23/7. Then it eats the x, so the line goes to the right. 41/7, this one, negative 41/7, it's open circle again because it's not equal, and it is not eating the x, so the line goes to the left. See how that kind of represents what we would expect from an or statement anyways, where the two lines go in opposite directions. And now we are ready for the interval. Okay, so starting on the left, that would go all the way to negative infinity, stopping and negative 41/7, which is not included. So close parentheses. Maybe I put those close to each other, but U for the OR statement. Now starting up at 23/7 there in green, which is not included, so open parentheses, and then going to infinity, which is never included. So there's our interval. That's really the only part we actually needed on this one. I like these types. Now, do be careful, because again, if this was an exam, even though it's not, and if you pull this kind of garbage, it just, really you're wasting your time after that, because you shouldn't be combining these, 19 and 5 right there, with addition, because it's out of order. It's out of the order of operations. And in fact, again, please don't distribute the 5. Again, it's positive, so it's not really going to make a huge difference, but my recommendation is to not, because, well, you'll find out here. So let's subtract 19 from both sides, because we do want to isolate the absolute value, though, right? So that's going to zero that out. And we got this absolute value, that's multiplied by 5. This is back to equations, though, so I think that's pretty good. That's going to be negative 80. Now, this should make you suspicious in the beginning, because it was a negative value right there. It's still negative, which should still make us suspicious, but I still need to divide by that 5. If that 5 were negative, I could continue with this problem. Because it's positive, though, what do you end up with? 130, 116? Negative 16, okay? So now we get the absolute value. It doesn't really matter what's on the inside right there, because I'm saying that it's going to equal negative now. That can never happen, so that's already right there at D&E. Now, if you had distributed the 5, or maybe even combined the 19 and 5 right there, you may have made the mistake of continuing on with the problem. But again, it's just a D&E type problem. You can put the stuff in between here, but it doesn't really matter what's on the inside now. You're comparing this to a negative, so D&E does not exist, no solution, however you want to say it. Here's an absolute value equation again, and even though there's two absolute values here, just like we saw when we did this lesson, a lesson on this one, just, don't be overwhelmed by the double absolute value. Just treat the first one as though it has the absolute value, right? So you're going to split this one up. So that'd be 8x minus 2. It's going to equal just whatever's in the other absolute value, 6x plus 18. So nothing changes with the first equation. But again, we should only end up with 2 answers on this. But now I'm going to take that 8x minus 2. I'm going to keep it the same, but I'm going to take the opposite of the second part. Now, I showed it like this. Negative with parentheses 6x plus 18. Some of you skipped that step, which is perfectly fine, and just showed 8x minus 2 equals negative 6x minus 18. And some of you may be wondering, well, how we got that. That's because this is kind of like a phantom negative 1 that we distributed into this parentheses to get this. But some of you, I think, like to just change the signs of the second expression, which is, it's okay to do that, okay? Because it's accurate. So now we have these 2 equations that we now need to solve, and, well, it's pretty much the same thing for both. So, for both of these, what the heck, I'll put the x's on the left and the numbers on the right, but for both. So that means I'll do 2 steps in one, just to make this go a little faster. So add 2 to both sides on both, while also adding 6x to both sides. Okay, so this will, well, I guess I'll have to subtract 6x right there, right? Be careful on that, because I almost made a mistake. So there's my zeros. 8x's minus 6x's is 2x's equals 18 plus 2 is 20. That's going to turn out nice. And there's my zeros again. 8x's plus 6x's now is 14x's, though. This will equal negative 18 plus 2, which is negative 16. That one doesn't look so good, but the first one does. Divide both sides by 2. Hey, x is 10. That's not too bad. The second one, divide both sides by 14. You'll have to simplify this. You need to simplify that. The calculator will do it, by the way. X equals negative 8/7 with the calculator on that. So we get the 2 answers for x on this. If you write it like this on the exam, even though this is a review for the quiz, on the exam, if you wrote it like that, that's fine. On the quiz, I believe they want you to write it in the one box, x equals 10, comma, negative 8/7. Which, I mean, it's more simplified, but it's just more work too. But, and again, you're welcome to flip those if you'd like. It's not going to change the answer. If you prefer to write this as x minus 6 absolute value is equal to 9 right there, okay? If you did that, that would be fine. Try to make that, there we go. It's not going to change your final answers, okay? Now, I'm going to work with the original because we can. I guess unless you guys want me to. Okay, we'll work with it as is then. So let's just keep it like this. And nothing to do on the outside of that absolute value. So it's nice we can just already split this up. So I'd say 9 equals x minus 6 first. But also negative 9 would equal x minus 6. Okay, so again, I'm changing what it equals, positive and negative, the two opposites right there, right? And yeah, this one's not too bad. Just add 6 to both sides of both equations. Zeroing that out, so 15 equals x on this one. And then over here, still add 6 to zero that out. It's just now it's negative 3. So x could equal 15 and x could equal negative 3. You can check. Let's try 15 minus 6. That's 9. Absolute value 9 is 9. That's true. Negative 3 minus 6 is negative 9, but it's an absolute value of negative 9, which is 9. So that's also true. Here we go. Inequality is asked for us to solve and graph and the interval. So again, this is a 3-part question on this one. You guys take a minute, try this one out, then we'll go over it. So, yeah, let's go and start here with the inequality. But remember, this is 3 parts. So whatever you do to one, you got to do it all 3 now, right? So right here, I'm going to subtract 3. But if I do it there, I got to do it to all 3 parts of this compound inequality. That is just to zero that out. I still will drop the negative 6x. Oh, that's interesting. So 9 minus 3 is 6, and then 15 minus 3 is 12. Now, right now, this is the inequalities that I have, right? I got 6 is less than or equal to negative 6x, which is less than 12. But you'll notice right here that I'm now going to divide by a negative 6, right? That coefficient is negative. Since it is negative, I got to flip both inequalities right now, okay? So that's going to make that greater than or equal to or greater than. So what do we get? 6 divided by negative 6 is negative 1, and 12 divided by negative 6 is negative 2. And right now I just got the phantom 1x right there in the middle. Okay, so it kind of flipped, but it's still, see how it's still sandwiched? It's bigger than the smaller number, which is negative 2, and it's still smaller than the bigger number, which is negative 1 right now, okay? So now I'm ready to take this to the graph, and well, I guess 0 would be over here. Negative 1, negative 2. Okay, so if I looked at just this first part here, that's negative 1 is greater than or equal to x. That would give me a closed circle at negative 1 because it's equal, and it's not eating the x, so we'll go to the left. And then the second part there, x is greater than negative 2, gives us an open circle at negative 2, but now this goes to the right. So we end up with this just the line in between there for the graph, okay? And then finally the interval, which I need a little bit more space for. This graph starts at negative 2, which is not included. So open parentheses, and then it goes all the way over here to the right at negative 1, where it stops. Negative 1 though is included, so that's a square bracket. So there's our compound inequality, our graph, and then and we'll do this one. I just want set builder notation. And I don't know. I think that sounds more difficult than it is. Here, let's show you, okay? So once again, whatever I do to one, I got to do it all 3. And right now I can see that the coefficient's positive, so I know there shouldn't be any flipping of the inequalities. This should go pretty well. But first off, let's just subtract that 4 to zero it out. This will isolate the x's, but if I do it to 1, I got to do it to all 3. That zeroes that out. Negative 11 minus 4 is negative 15. And then 24 minus 4, boom, 20. Still drop my 5x, and none of that changed the inequalities. So last thing here, divide all 3 parts by 5. So yeah, that becomes a phantom 1x. I'm comparing this with negative 3 and positive 4. And again, that coefficient was positive, so nothing changes. Oh, I forgot my equal part, didn't I? There we go. So yeah, now we got the compound inequality. But this one wants the answer in set builder notation. So you may be wondering what that crap that is. Remember, it's got the fancy brackets with the x and then the little line x such that x, well, that's where we just kind of plug in our, see if I can make that better. all we're doing here is plugging in the inequality we just found into a set of parentheses. I don't know that I'll get better than that. Solve and graph inequality. So compound is just an or statement between there, no problem. The great news here is that you get to do this twice, and it's so fun. So I'm going to start with the one on the left, and I'll do this one in red, and then I'll graph it in red, because it'll look pretty. Then we'll do the interval at the end. Okay, so let's add 4 to both sides, zeroing that out. Yeah, zero that out. Drop our 4x. Now is less than -8 plus 4 is going to be -4 there. Now divide both sides by the coefficient 4. That's positive, so it's just going to keep that inequality the same. X is less than -1. So that one's solved. Let's go to the next one. More principles of equality. Add 3 to both sides of the inequality. That zeroes that out. -1 plus 3 is +2. And then we'll need to drop that 2x. So 2x is greater than or equal to 2. Let's divide both sides by 2. And x now is greater than or equal to 1. And yeah, since I know it didn't ask for the inequalities, but I'm still going to put an or statement in there. I don't know why, it just makes me feel good inside. So right in the middle, I'll put 0. To the right's +1. To the left is -1. And they are not equidistant, not that I care. So x first off is less than -1, so there's an open circle at -1, because it's not equal. And then it's not eating the x, so the line goes to the left. That's my red one. The purple one, x is greater than or equal to 1, so I'd have a closed circle at 1 there, because it's equal now. This one eats the x, so it goes to the right. There's the graph. And now that I have the graph, I'm ready for the interval. So as far to the left as I can go, that's an arrow, so it will go all the way to -infinity. I can make that a little bit better. It stops at -1, which is not included, so there's parentheses, close parentheses. And then we'll unite this starting at 1, which is included, so square brackets, and this line, this purple line, goes all the way to infinity, which is never included. So even though it didn't really ask for the inequality, I have it. And then, of course, we got the graph and then the interval notation. It did say to write the answer in interval notation. There's the graph too, whatever. All right, hey, this one's got bigger. Like we got 2 equations. And in fact, I don't even know that they're bigger. There's some distribution. And the second one, yeah, maybe we have to use 2 or 3 principles of equality. No problem. I still don't see any combining like terms. I'm still going to start on the left, though. So first off, for me, distribute this 2. And yeah, some of you would use that trick. You'd divide both sides by 2. Go ahead. You're going to get the same answer. So 2 groups of 3 x's, that'd be 6 x's. And then 2 groups of 7, that'd be +14. And we're saying right now this is less than or equal to 2. Okay, so now it becomes a problem like we did on that last one. So now I'll subtract 14 from both sides. Drop my 6x. Still less than or equal to, but now -12. Well, that's convenient. Divide both sides by the coefficient 6, and I get x is less than or equal to -2 now. And again, that inequality did not flip because the coefficient was positive, or you could say that we divided both sides by positive. Same thing. Now this is an and statement. We'll worry about that later, but I'm just going to solve this this next one. And you know, I'm gonna put the x's on the right, and I guess I should do this in purple. Okay, x's on the right, numbers on the left. And again, I'm doing that purposely in order to force the coefficients to be positive. Now, if you put them on the left, you're still gonna get the same answer. It just will look a little different. I'll show both answers, no matter which side you put the x's on. Okay. So for me, I'm gonna have to add 7 x's to both sides. See, this is gonna make that coefficient a positive 15 x's right there, zeroing out the -7x. And then -49 from both sides makes that -45, which is less than 15x. Now I'm ready to divide both sides by the coefficient of 15. So I get -3 is less than x, phantom 1x if you'd like. And we don't usually need to put the and statement in between there. Remember, you could just rewrite this as a compound inequality, if you'd like. I'm okay if you put the and statement there, though. But yeah, you could compare x with first -3 is the smallest, and then -2. Should be bigger than -3, but less than or equal to -2. All right. So now that we have the compound inequality, or the and statement, which is still a compound inequality, I'm ready to graph. So I'd have 0 here on the right, and then I'll put -2 right here, and then -3 right here, just some spacing there. And starting with -2 in red, that'd be a closed circle. I know that's offset, that's on purpose because I ran out of space. It's not eating the x, so that would go to the left. I'm looking for the and statement, so for the intersection of these two lines. Then at -3, it does not equal x, so that is an open circle. And that one is eating the x, so this one goes to the right. Okay, so that means everything in between these two values would be where the intersection occurs, and that is the graph. And now for the interval. So this line, it starts at -3, which is not included, so that's open parentheses, and then it will go all the way till you get to 2, so that's where it stops, and then it's included because it's a closed circle, so we got a square bracket right there. So now we got the inequality, the graph, and the interval. Boom. Yes, that is, make sure you don't forget those little things like I just did right there, especially on a quiz or a test. That doesn't go very well. So on this one, we're gonna graph it just says the graph, so we won't worry about the interval at the end, although you could do it if you'd like to, okay? So principles of equality, right? I'm gonna start here on the left. 15x plus 5 is greater than 11x minus 3. I'll do this one in red. And again, I'm gonna do the two principles of equality in one part here just to save some space, and I guess to save some time. I'm going to put the x's on the left and the numbers on the right. Why am I doing that? Because there's more x's on the left than there is on the right. So that means when I zero out these 11 x's, I should have a positive coefficient, which means I won't have to worry about flipping the inequality, which I think is pretty good. So let's look at that. Subtract 11 x's, right? It's going to give us 4 x's there on the left, zeroing out the 11 x's. But I want to zero out that plus 5 there too, so subtract 5 from both sides, which does zero that out. -3 minus 5 is -8. Some convenient values here. So I got 4x is now greater than -8. Finally here, just divide both sides by the coefficient of 4. Now that 8 is negative, but the coefficient is not. So don't forget this, and I know I said this before, I just want to emphasize this because I don't want to take the points away on an exam. Just because this number is negative doesn't mean we need to flip the inequality, right? It's only if the coefficient is negative and then you divide both sides by a negative, right? So x now is greater than -2. And yeah, let's go to the next one. Here, we'll do this one in purple. So I'm going to put the x's again on the left and then the numbers on the right because there's more x's on the left. So let's see, yeah, again, two principles of equality in one. I'll get rid of the -9 first, so I'll add 9 to both sides. Zeros that out. 12 plus 9, boom, 21. And then the positive 14x, yeah, subtract 14x from both sides. 17x's minus 14x's is 3x. Now it's greater than or equal to 21. Yeah. And then divide both sides by 3. So now x is greater than or equal to 7. Right, but this is an or statement, and it wanted the graph for this one. So that is the inequalities, compound inequality, but now we need the graph for this one. So right in the middle, I'll put 0, -2 to the left, 7 on the right, because it's positive and negatives. So let's start with -2. Open circle, because it does not equal the x. This one does eat the x, so it goes to the right. And then with 7, right? So this one is equal to 7, so you could give us a closed circle there. It's eating the x, so this one goes to the right. Now I'll finish that red line there, see, like this. This is an or statement, okay? So it doesn't have to be both. It only has to be one or the other. So even though they do intersect here, which is okay for an or statement, it wouldn't stop at 7. It would continue going to -2. I guess I'm pointing this out more for the interval, even though we're not doing that. So really the graph should just look at, yeah, so there's the line. This is the actual line we need. We wouldn't need this purple dot right here. And again, this is more if you're doing it by hand, but on the computer you would just give yourself an open circle here and then drag that line to the right. This one's so great. because not all that work that we've been doing, right, with all the principles of equality. Hey, look, these ones are solved. So it does say that it wants the interval. So sorry if this, if you feel like this is a waste of time. I'm still going to do the graph because it makes me feel good. So there's a 5 there on the right and then negative 10 on the left. Wait, so no principles of equality. That's what I like about this problem. No principles of equality. It's just already solved for us. So I see that x is greater than negative 10. I'll do this one in red. So that's an open circle. It's eating the x, so it goes to the right. And then also x is great. I'm sorry, 5 is greater than or equal to x. So this would be a closed circle at 5, but it's not eating the x, so this one will go to the left. So again, we want the intersection. You can extend these lines, but they'll only intersect between negative 10 and 5. Oh, it does want the interval. So starting at negative 10 is where this line starts. It's not included because it's an open circle. So open parentheses there. And then this will go all the way till 5, which is included. That's a closed circle. You know, it kind of looks like it's not. There's our interval. Boom. And just a quick hypothetical here. If this was an or statement, it would just be the full line right there. And then you'd have negative infinity to infinity. So that's the difference here. An and statement is just the intersection of the two lines. An or statement is just one or the other. So you can kind of hop back and forth between the two lines. No principles of equality on this one. So no need for it, right?
I'm done.
All right. So, well, yeah, we don't need any of the interval for this one, right? So I'm just doing the graph. Starting with the x is greater than 20. So that's open circle at x. 20. It's eating the x, so this one goes to the right. And then this next one at 25, that's going to be a closed circle because it's equal to the 25. This one does not eat the x, so it goes to the left, though, okay? I'm going to extend these lines because it is an or statement. And do be careful because sometimes we look at problems like this and it's like they intersect, so it has to be just in between there. No, this is an or statement. So not only does this go all the way to negative infinity on the purple line, but the red line is going to make this go all the way to positive infinity over there, okay? So what would the final graph look like? Remember, this is where I'm covering this on purpose, but it's going to go all the way from negative infinity. It's not going to stop at 20. It's going to continue, not just to 25, but it's going to go all the way to the right to positive infinity right there. So again, the interval, I'm going to do this, even though I said I wouldn't, but this goes from negative infinity to positive infinity. Done. I know we only needed the graph, but a little bonus on there with the interval. You need to rent a car while on vacation. The rental company charges $25.35 plus 26 cents for each mile driven. If you only have $210 to spend on the car rental, what is the maximum number of miles you can drive? We'll round this to the nearest mile. Fair enough. Okay, so I'll set this up. And while you don't really need the inequality for this one, I'll still set it up as an inequality. Okay. So let's see. We'll say cost, right? So kind of how we set this up. I think I used money spent before, but cost. So you see the actual cost for you of the rental, and we're gonna compare the cost to, or the eventual cost to how much money you have. Oop, there we go. There's a dollar sign. How much money you have, okay? Now, you can't spend more than you have, so you could spend equal to. So there's our equal sign part of this. In fact, I'll put an equal sign, but what you want is for how much money you have to be greater than or equal to the actual ending cost on this, okay? So the cost is going to include two things. It's got that charge. I'm going to put it as a fee. And then they're going to also charge you for the mileage on this. And so the fee is $25.35. And then how much do you get charged for mileage? Now it's 26 cents per mile. And since I'm going to need to define an x here because I'm going to be using an x. So I'm going to say that x equals number of miles. I'm just going to put number of miles. You can put number of miles driven if you'd like to be a little bit more specific. So for the mileage, you're going to be charged 26 cents. So that's 0.26. That's 26 cents. And then you're going to multiply that by however many number of miles you're going to go on this. Let's add these two together. And then this is less than or equal to however much money you have, which it says you have $210 to spend, okay? So you can't go over that, you can get equal to it, but it should be less than that. Otherwise, you've gone over however much money you have. So now this becomes an inequality that we can now solve by subtracting first $25.35 from both sides. I know you probably think I shouldn't, but I need my calculator for this one. So 26 cents times the mileage, less than or equal to. So this gives me $184.65, and that's for mileage. So right now, you'd have $184.65 for mileage. Remember, this is, since this is a word problem, we should be able to interpret this as we go. And now I'm going to divide both sides by 26 cents. So 0.26, 184.65 divided by 0.26, enter, and I get X has to be less than or equal to 710.1923 and some change, okay, something like that. Now at this point though, because remember it's a maximum number of miles driven, and usually on problems like this, it's going to want you to round to the nearest mile, but it's not rounding to the nearest mile, even though it does say round to the nearest mile. Remember, there's usually some kind of application here. So even if this was in the 10th place value, if that was like a 5 or a 6, we wouldn't round that up because you don't have enough money to go 711 miles. So we're just going to round this down and say 710 miles. I'm going to put max. Maximum is kind of a long word for me, so that's it. Local high school is renting a facility for prom. The hall that they are renting charges a $175 cleanup fee. In addition to the cleanup fee, they charge $44 per guest for food and drinks. If the school has $10,603 available, what is the maximum number of guests that can attend without going over the budget? All right, so we got a budget. This one's kind of like that last one. I'm going to compare cost, like actual cost. Oh, where'd that go? Cost, there we go. And I need to compare the cost to the budget that actually is there, okay? Or like that last problem is the money that we have, right? So what is included in the cost? Well, it says up here that there's some kind of cleanup fee. So you're going to pay that no matter how messy it gets. So I'll put that down, a cleanup fee. And it did say that that was $175, so I'll put that down. And then in addition to that, it says that it's $44 per guest. Now, we don't know how many guests. That's kind of what we're trying to find. Remember, that's usually hidden in the problems. What's the maximum number of guests? So it says what's the maximum number of guests. That always has to be our variable here. So I'm just gonna put number of guests because it is variable. But since we're solving this like an equation, this will tell us the maximum, especially if we set up the inequality correct. So you have the cost for cleanup, and then you have the cost for the guests. You can put number of guests if you'd like. Now it's $44 per guest, so it's $44 multiplied by the number of guests. If we add this together, we get the cost. Next up, we see that the budget is $10,000. $10,603. I don't need the decimal on that. And so the budget needs to be the bigger of the two. Okay, so it needs to be, whatever it costs needs to be less than that, but it could be equal to if we get that far. Okay. And yeah, we definitely don't want to go over budget, which means the budget, again, needs to be the bigger of the two values. Now I'm ready to solve this. So first thing, I would subtract 175 from both sides. To zero that out. So just for guests, even though it's $44 per guest, looks like 10,603. And just going to the calculator, minus 175, enter. Looks like just on guests, they will be able to spend $10,428. And now divide this by $44 for every guest. This will tell us the maximum number of guests. So take that divided by 44, enter. Oh, it came out exactly 237. I will label this because it is a word problem in guests. So they can bring, if they can bring 237 guests, they'll be at the maximum amount of the budget. As soon as they have 237 guests enter, then it's, then they gotta close the doors. So yeah, write the answer in interval notation. It did not ask for the graph, but I'm still gonna do it because it helped me. So, first things first is to isolate my x's, so I'm gonna have to subtract 8 from both sides here. That zeroes that out. I'll drop my 8 x's, which is now greater than or equal to 8. Now divide both sides by 8. I don't know, I put a 4 there. But x now is greater than or equal to 1, okay? So, we have that, and on the graph, there's my 0. I'll put 1 and 2. At 1, would have a closed circle because it does equal to 1. And this one's eating the x, so the line goes to the right. There's the graph, but we do want the interval for this one. So it starts at 1, it's included. So we got a square bracket there. This goes all the way to infinity. Done. Use the given sets below to find the new set. Enter each number separated by a comma. If there are no numbers in the resulting set, leave the answer blank. Okay. This is an and statement right there. We do have the and statement. And so we need values that are part of both A and B. Now, you wouldn't have to write it like that as far as I know, but we do need fancy brackets, okay? So, is there values that match? Let's see. I see a negative 23 in both, so I'll put that one down. I don't see negative 8s that match, no 0s or 13s. I do see it, and be careful on this, I do see a 13 and a negative 13, but they're opposites, so you can't include those. There's no 52 on this one, and then the 91s, there we go. See, 91s match, so I'll put this one in, 91. That's as many as I can see that match. The negative 8 and the negative 18 are kind of throwing me off too, but they are not the same, so there we go. That is the set of A and B right there. Now, do recall, if this was an or statement, which could happen on the quiz, you'd have to include not just all of these from set A, but any of these other ones from set B, making sure not to duplicate any entries. So you wouldn't want to put negative 23 twice or 91 twice. Just put them once, even in the or statement. All right, then this one. Oh, this one just wants the inequality. Wow, that's nice. So let's solve it then. This one's only one step, so just divide both sides by negative 6. Now, we get, like I said, we get on kind of a roll right here, and it's like, dude, negative 3 is less than x. No, because remember, these we divided both sides by a negative right here. It's got to flip that inequality. It's not less than x. It's actually greater than x right here. Oops. There we go. Do keep in mind as well, at least if this was an exam, you could say that x is less than negative 3. That would work too. Both of these are good. The same thing.